Alright guys, so as you see you've got a packet to do for today. I'm going to give you this little video. It should be self-explanatory, but I figured I'd give you the video just to help out and make sure everything's clear. Okay, so you've got two parts, and what we're working on, the whole goal we're working on is to putting together, designing complex circuits to get a certain resistance that we want. Okay, there's lots of reasons to do that. It means you can control what the current is in certain areas by throwing other resistors in. But basic idea is that's what we want. We want to get a certain equivalent resistance in order to get to build a circuit. So for part A, the first step of doing this, oftentimes part A, is to figure out what kinds of equivalent resistances you can have. So you've got a 2, a 3, and a 6 ohm resistors. Okay, you can have like a bunch of 2s, a bunch of 3s, or a bunch of 6s. You don't have to just use one of each. Okay, but all you've got is 2s, 3s, and 6s. So the first step you're going to do is you're going to find the equivalent resistance of a bunch of combinations. You've got the first 6 combinations that are written out there. So to do a 2-2, so R2-2, and we're going to do them all in parallel. The reason we're going to do them in parallel is because series ones are really easy. 2-2 in series is just 4. Okay, but for some of them, for doing parallel, it's a little less obvious. So R2-2 in parallel, well, we do 1 over R2-2 is equal to 1 over 2 plus 1 over 2. And we get that R22, 1 over R22 is equal to 1, so R22 is equal to 1. Okay? So you're going to go ahead and do that with 5 more combinations. They're written out there, you're going to fill in the table. After that, you're going to do some 3 resistor ones. Okay? And all you would do there is you would add another fraction at the end. The first 3 you do, you're not going to record in the table. Okay? After that, you're then going to do 3 more that you are going to put in the table. And you should be able to figure out why you wouldn't put those first 3 in the table. Okay? Okay, that's part A. Part A should be pretty quick. Part B is a little more complex. In part B, I've given you the equivalent resistance that I want. And I want you guys to solve for what circuit you would have to build to make that. And so to do that, you're going to put resistors in series until they add up to it. So my example here is I want our total to equal 6.7. Okay? If I want that, I got to find a bunch of resistors that add up to that. Now you might be like, well, let's put a 6 out there and see what happens. No. Now the best thing to do is to figure out the decimal first. Okay? So from your table, written in there, you should know that there's nothing that ends in 0.7. Okay? Now there might be one that ends in like 0.66. Not good enough. We're going for the actual like exact thing. Okay? So in order to get it, we do have that R22 is equal to, sorry, not R22, R23 is equal to 1.2. Okay? Yeah. We also know that R33 is equal to 1.5. So if we combine those two together, we would get 2.7. Okay? We could then add 2 more 2's to get to 6.7. Okay, so once I get that decimal out of the way, it's easy to get like just the whole numbers. So this circuit that I would draw, and this is what I want you to put on your sheet, would be battery. Okay. First resistor set is going to be my 2, 3 in parallel. Then I'm going to put a 3, 3 in parallel. Okay, but both of these chunks are just in series with each other because we want to add them. Okay. I would then put a 2 and then another 2. And now I have a circuit with a resistance of 6.7. So the key is figure out what chunks of this, when added up, will add up to the total that you're looking to do. All right? When you're done, you can leave. Have a good one. See you tomorrow.